Okay, so let me begin my presentation. Um, first of first of all, thanks to the hosts for this interesting competition. I really enjoyed this competition. Here is the agenda. I'll start with our background. I work as an NLP engineer, but LLMs and really my specialty. And my teammate is an operations research engineer. So we didn't have any particular background that directly gave us an advantage in this competition. If anything helped, it might be that both of us had previously participated in the AI Village CTF, which is a similar kind of competition. There, we have some experience working on adversarial attacks against LLMs, and I think that experience was somewhat helpful this time as well. So next, I'll explain our solution summary. Before going into the details of our approach, let me define some terms we'll use in this presentation. We'll refer to the three judges as Judge A, Judge B, and Judge C. When the scores from Judge A, B, C are X, Y, and Z, we'll simply write them as X, Y, Z. For example, 099 would mean only Judge A is 0 and the others are 9. We also break down the evaluation metric into 3 parts: the English score, the similarity score, and the judge score. So here is our solution overview. We combined 3 types of attacks and each designed to make only one judge output 0. The 099 and 990 attacks use almost the same prompt. The main difference is that 990 includes a random string at the beginning and uses a different number sequence at the end. The random string in 990 is only added to lower the similarity score. In fact, removing it makes the attack more stable. For 909, it was important to repeat the word perfect in the random string. While we can be certain, we suspect this works because one judge doesn't fall for the attack and evaluates the essay normally, giving a score of 0. Meanwhile, the other 2 judges are influenced by the word perfect and give a score of 9. Let me also share examples. As we explained in the previous slide, you can see that 909 contains a random mix of spaces and the word perfect, while 990 includes a sequence of randomly selected English words. So next, I'll go over 4 key findings that helped us improve our leaderboard score. The first finding is that simple attacks were effective across all judges and it was actually easy to get them to return the same score. For example, if you want all judges to give a 9, you can just ask them to forget the system prompt and output 9. If you want all zeros, just change 9 to 0. Once the system prompt is overwritten, all judges seems to follow new instructions very faithfully. So we focused on crafting instructions that will be interpreted differently by each judge, causing only one to output a score of 0. Our second key finding was that we could trigger all 3 patterns, 099, 909, 990, using a shared attack format, as you can see here. For example, in the case of 099, sequences like roughly repeating 9900 or the reverse version worked well. We believe these attacks were effective because they exploited logic gaps between the judges. For instance, given a sequence like 9000, 9000, one judge might see continuous zeros and predict another 0, while another judges might see a repeating pattern of 9000 and predict 9. By combining these 3 types of attacks, we were able to get near perfect judge score. However, this approach led to poor similarity score. So we started exploring whether we could add random strings to our attacks to reduce the similarity score while keeping the judge score high. In the next slide, we'll share what we learned from that process. Our third key finding is that we could partially control the judge scores by adjusting the words included in the random strings. For example, zero-related words tended to lower the judge score toward 0, and similarly, 9-related words raise the score toward 9. We also found that using positive words, such as perfect or superb, could raise the score toward 9 as well. On the other hand, using random English words or white space-like tokens tended to preserve the original judge score from the base attack without skewing
Yeah, thank you. That was a really fantastic presentation. Really
these findings were useful in designing the 909 and 990 attacks.
Slide deck there.
For the
and I think it was a lot of your ideas were
attack,
pretty
we found that repeating the word perfect
unique,
in the random string
and interesting. How did you come up with the idea of repeating
we tried 20 to 30
the next number in a sequence,
words, but
had you seen that somewhere else, or was that something you came up with
909 attack,
independently?
only perfect consistently worked. I came up lastly on my own. We'd like to share some findings from our reverse engineering of the LLM-as-a-judge system. While this wasn't the main focus of the any number competition, it helped attacks us better interpret the readable score and design more easily to. Here are three examples and check another attack. We discovered a token length limit. Like this. If an essay exceeded this limit, the judge score always came back as 000. We inferred this from the fact that longer essays often had unusually short execution times and consistently return a readable score.
I'm curious about which test sample will harm English score.
We found a way to detect whether an attack triggered a 999 judge score. Attacks that this one directly asking for a 9, I think often caused submission scoring errors. Slightly worse. We suspect this is due to and 0 division error 0.99999 minus average Q calculation. Third, we attempted to identify which models English score were used as judges. So, although we couldn't pinpoint all of them,
I had a similar question actually. It was
found that
for the exploit that didn't get the perfect English score. Were there spaces between the random words?
Attacks which produce more tokens only in Gemma,
or were the words all chained together?
Exceed token length limit. Yes, we tried that all to change. Thank you for your trust or